All right, we're going to get started with our last symposium for today for ECN 2024. So we can come back to our seats. So this last symposium is a little bit different format. These are going to be our lightning talks. All but one of them are pre-recorded. Our thought with this is a way to replace the traditional posters that we've been trying to figure out how to continue to accommodate. So we're hoping to move more towards these pre-recorded, short 2 to 5 minute videos. And also this symposium has wrapped into it the Specimen Spotlight Symposium that we were trying to start for the first time this year. There's some really cool short videos you'll see here, and this is something we're hoping we might be able to continue into future meetings. So you can find the contact information for all the presenters in your program. So if you have questions, you can reach out. We won't take questions during this session, but many of them are in the room, so you can find them afterwards as well. So the first lightning talk is from Isabelle Betancourt and Evan Waite.
Hey, my name is Isabelle, and I'm the current collection manager for invertebrates at the Natalie at Arizona State University.
And my name is Evan Waite. I'm a PhD candidate at Arizona State University studying rabbits or primates.
We wanted to break into the topic of artificial intelligence and entomology collections. It's not a topic that has been discussed at previous ECN meetings, yet AI is rising up more and more in the collection space, at least within the nearby repository here at ASU. This past August, Evan and I attended the Betancourt workshop hosted by the Genomics Institute at Ohio State University. It was a hackathon-type workshop that brought together and made space for a diverse assemblage of 29 machine learning researchers and about 4 collections professionals to explore participant-proposed questions that paired machine learning with images of the neon biorepositories of US specimens. Machine learning and artificial intelligence has been a big theme in the requests that we've received for vertebrate bones at the biorepository. The scope of the NEON project fits machine learning needs very well, as the NEON project is collecting standardized organismal and environmental data across 30 years at 81 sites across the US. We've had many researchers, especially ecologists, submit proposals to use specimens in AI projects to identify specimens in our bycatch or to measure properties of the gill specimens, for example. Our collection consists of pinned insects organized by year and site collected, and we have both pin beetles and beetles stored in containment tubes in ethanol. The beetle quiz event focused on our crab collection, and only 4 of the participants had ever worked with insect specimens before. So Evan gave a presentation on what goes into identifying ground beetles species.
And after that presentation, it's clear that this presentation was very much needed because the other participants didn't understand the complexity and the nuance that goes into identifying these specimens. And that was the expertise that we were able to bring to this workshop, and that was the expertise that you as collections professionals can bring to other AI or machine learning researchers that may want to use your collection. So after this presentation, we broke out into groups, and the group that we were working on, our project was attempting to identify ground beetles with photographs. So we took bulk photos of the neon biorepository beetles and ran them through this program called BioClip, which was trained to identify things to the family or genus and species level. And after our first run, we were not very optimistic. The initial run had identifications that were incorrect at the subfamily level, as well as suggesting species that were not found in our target area. However, because this was a hackathon-style workshop, the whole goal was to improve and deal with these issues as they arose. So we did make some minor modifications to BioClip to increase its success. First, we trained the program on further taxonomic levels of the tribe and subfamily to see where the program could accurately identify the specimens to. And we also restricted the species pool from all parameters to just the parameters known from the particular site where the specimens were collected. And this did actually increase our success. So from the same photo from earlier, we actually have 3 now that were correctly identified species out of the 16 total. This is obviously not the best track record, but it was better than what we started with. And so then we examined 8,700 photographs of neon crowds and found that while it was initially identifying them incorrectly as subfamily, now it's identifying them correctly over 75% of the time. And this accuracy did decrease with taxonomic specificity, but in these later runs, it was identifying specimens and species about 25% of the time correctly. And so overall, we thought this was a really successful workshop because oftentimes other researchers will come into the collections, get our natural history expertise or get our specimens identified, and then take off, leaving us with an acknowledgement if we're lucky. However, this workshop is really well set up for collaboration, where the sites and projects, or the groups and the projects were formed on site, so you can float between different groups if you wanted to work on multiple projects. We also really felt that the machine learning folks valued our expertise and listened to what we had to say, and they even came to us for input all along the way, even though we only had expertise with the inside side of things and couldn't really help with the computer side of things.
Yeah, so in addition to what Evan said, some key points that we want to emphasize are that we have specimens and expertise that's valuable to computer scientists using AI and ML, machine learning, and they don't know what they don't know. We do, so that's enough. We also emphasize that specimens will continue to show that we can unlock their value in the era of AI. It's this exciting new tool that we can use. And so we encourage you to think about reaching out to machine learning researchers in your area to see what questions you have about exploring your collection that they might be interested in exploring with you. So thanks everyone, and if you have any questions, feel free to reach out.
Thanks, Ed.
Hello, ECN. My name is Hori.
Our next speaker is Taylor Hori.
As part of the NSF funded the digitization project, I create finished stocks of specimens in 360 degrees. This poses a unique challenge when we need to set an x-axis start and stop that also truly rotating worldwide length. So far, the best guidelines I've found online say to, quote, make certain we go far enough in those directions to keep the subject in focus regardless of the rotational position. As I train more staff in the microplex system and creating 3D image suites, I've needed to define this process to eliminate the guesswork. We start with the bee facing the camera with slightly canted to the end of the abdomen, wing, or leg, whatever is farthest away from the camera lens. The way our microphone system is set up is also having to stay aligned at 0 degrees. Because the camera distance is fixed, we can imagine the focal plane is the bee passing through or breaking this plane for each image frame. We set the start position when the bee is closest to the camera or before the focal plane. When you see this in live view, we'll watch the bee pass through where it's in focus from the head through the abdomen, setting the start position past the most distal portion of the specimen, whether that's the abdomen, wing, or a portion of the leg. Now, to account for the bee moving through space as it rotates about the y-axis, you'll want to select the 3 vertical lines on your snapshot and rotate the y-axis 180 degrees. The bee's abdomen is now facing the camera. Again, imagine that you're breaking the focal plane as you move the bee away from the camera along the x-axis. You'll see the bee pass in and out of focus from the head to the abdomen, from reverse of what you saw before. Once the bee is just out of focus, you'll set your stop line. Your start position, stop position, now account for when your specimen is as close to the camera and as far away from the camera as is possible as it rotates through 360 degrees. There are some instances where this process doesn't work. Generally, I've found this happens when the specimen has a significantly long or large abdomen. I forced the example here by stating the bee with its abdomen facing the camera, and one workaround I have is to close set a start. Meaning, I position the bee where I want to start the image stack, but I don't program it on my stash. And then rotate the bee 180 degrees and check if the bee remains out of focus. If it's not, like it is here, and then move the stage towards the camera until the specimen is out of focus. This is now the correct start position to ensure the entire specimen is captured at all orientations around the x-axis. From here, the site can start, and then program your endpoint for normal. One last thing, some of you may have thought that when we turn the specimen from 0 degrees to 180 degrees, the bee moves out of frame while out of focus. You could reduce the magnification, but I like to keep the zoom to maintain a high level of detail. You would just need to delete the out of focus images before you start. You can see the difference in the final results. Thanks for watching, and I hope this helps with your structure and removes the guesswork from your imaging projects. I'm currently trialing different methods to improve image capture through modeling and stop editing. Let's connect ECN or via email to discuss.
I'm going to be taking you behind the scenes in the meeting section. The hair is so strong on private in the air. And some of the things that we set out as part of our flow collections. We use this area, we can public talks, and there is something. Over there in the corner, we have the recently acquired Gilmore collection of long-form beetles. This is recently presented by the Museum of Doncaster. And this is about 25,000 long-form services that provide thousands of forests for the moment. And one point, bringing that London background, and we're inside the terracotta facade of the original watercraft building. The outside are available.
specimens are like composted and are raised up, and then we can use it in all.
And just around the corner, we just go back to the weeks of brown and red color. And what we've got here is two boxes for branches, weevils that have been identified by Betancourt, and we also like two from.
And like, what
The school in the state had outcomes, especially, years ago. So, the species in here obviously forms as large as the real standard ground system in general. And as you can see, there's not much space for additional specimens of species. So here's a draw, after our review. So we can unit trace. I am checking all the type statuses of all the historical types with the original restrictions, and I already managed to rediscover a whole load of original syntypes or even more types that was previously lost. Here we have a species that was only known from the type series, completely described in the 50s. But thanks to our recent project in Africa, I've managed to collect the longest series ever collected from the different countries.
That's fantastic. It is an objective, of course, to get forward. After four, and obviously, that's the fantastic.
Many qualified candidates apply, but one candidate was Dr. Stephen Barclay was offered the position and heavily accepted, but the start date of August 1st, which was just 3 short months ago. I heard that Stephen was down and you don't either. I'm going to introduce him to you, give you some details about who he is as a person, and give you some idea about how his directorship might compose the policy. Stephen is native of Mexico. Born and raised in Yellow, almost on the Arizona Mexico border, and for former surgery. His family owns restaurants there, and he is quite a chef. This is my assessment because he has taught me quite a few things about preparing and cooking for chilies, which is one of my passions. He has a passion for education, and I haven't seen where he came back. Stephen always loved the natural world, but had a non-traditional and winding path in college. Eventually, he received his bachelor's degree from the University of Mexico and became his research on biofuels. He went on to his master's in communication in Replogle at the University of Kansas, where he focused on the systematics and evolution of the Hori, no parity. Here he can be seen shifting his focus between his tiny beetles found in unique agricultural habitat and the vast beauty of the civil weedy savanna of Suriname near its southern border with Brazil. Stephen's interest encompasses several aspects of water technology. This interest and his research approaches mesh well with the faculty of technology, where he will continue his research on water fields, especially his little notary response, and maybe new areas of stewardship and water-based research with the awesome. I have found ECN very friendly, incredibly helpful with network curator for the last 3 or 4 years, and I know he will be welcoming to Stephen in his new role. Stephen, myself, all the directors, all the cases, and all that's the result. And Stephen's really gets you to one. Yes, that's over. And while the majority of those people are not many well-trained families. Thanks in part to the former director Chris and his many graduate students and postdocs, Alexis Church and Mike Fairman and Chancellor Park, Brittany Bowens, and Klein and Priscilla, and all of their unique libraries as well. Now our collections will be growing thanks to the new director, Dr. Waite. We already have White homes from the research of library specialist Charla and historic White and chief counsel and Polaszek and Barclay. Historically, the collection is focused on the southeastern U.S., but we will always continue to expand, and we've done so in the U.S. as well as foreign expeditions. Our new focus is the U.S. and Mexico and Brazil. We are also visiting Costa Rica with probably certainly Stevens or all as well as fine catch analysis for exhibitions. We invite you to our lessons for your research, or even return and look at the home project. So I'm going to close here, and thank you very much.
And our next lightning talk is going to be given by Matt Buffington.
Good morning. I'm not Andy Polaszek, but I play him on television. So I will be doing that right now. He had a little visa problem getting into the country. So I'm just going to read what he sent me as a script and answer some questions at the break if necessary. About 10 years ago, Matt Buffington gave an ESA presentation co-authored by Mike Gates and Norm Johnson on the various cephalic modifications of parasitoid wasps. I'd like to visit this area with a plea for speculation on the purpose or purposes of these modifications. Okay, I'm off by exactly one slide, I think. So this is what I was supposed to show during the last reading. So that's a thygitid at the top, dipriid, and some various celionids, Nanocathulu, Gnathocerophron. There appears to be a remarkable degree of convergence across 5 distinct superfamilies. The parallels between Gnathocerophron in the Cerophonidae and Incerticilio in the completely unrelated Celionidae are particularly striking. The discovery of a new species of the rare Cerophronid genus Gnathocerophron in Uganda prompted me to revisit this phenomenon in an attempt, so far extremely speculative, to discover the function of these cephalic modifications, which could perhaps explain the remarkable degree of convergence across these unrelated taxa. My initial speculation was that these projections could be used for digging into dense soil, an idea supported by the single publication concerning this behavior in the dipriid genus Coptera. The dorsal view of this Gnathocerophron species indeed suggests a couple of shovels. But looking at an additional cephalic structure, a bifurcate process equipped with pocketed setae or sensili arising above the apparent labrum, and so presumably a modified clypeus, appears to be too sophisticated morphologically to be another piece of a digging apparatus. Unsurprisingly, my preliminary quick and dirty analysis of the CO1 barcode, made possible by the recent publication of Christina Vasilida et al., compared with selected sequences on both BOLD and GenBank, suggests the new species is firmly nested within Aphanogmus, of which Gnathocerophron appears to be a highly derived lineage. The same result, irrespective of how the tree is rooted. Like several of Paul Dessart's apparently unusual Cerophronid genera, Gnathocerophron was already destined for synonymy. As this detailed study of male genitalia morphology by Miko et al. Had already suggested, Isvan told me last year at the LOSI meeting that independently, Bonnie Blamer's lab had come up with similar results for them with using their mitogenomic data. I'm grateful to all these who support various kinds, to my employer, the Natural History Museum, for supporting my research on these fascinating animals, and to Taylor and Francis, publishers of the Journal of Natural History, for the financial support that will hopefully eventually bring me to Phoenix later today. Thank you.
My name is Charla Replogle and Seago. This involves working with.
Hori.
My name is Charla Replogle, and today I'll be talking about centralizing Purdue entomological research. First, I'd like to give a brief overview of the located at Purdue University in Polaszek, here in Indiana. The park holds over 1.3 million different park classes. The park is the largest entomological collection in Indiana, and we also hold the most taxonomically accepted. The Entomological collection actually spans 9 cabinets and contains over 40,000 bios, with an estimated 400,000. Despite these impressive holdings, the park is separate from the Entomology, I'm sure many of you are familiar with. We like a single centralized database for all of our digitized. Different parts of the collection have been digitized throughout the years, different projects, and the data has been scattered across different portals, including student, project bio, resident, and scan, as well as average and the solution, what I'm going to show you today, has been a huge collaborative. Starting in early summer of this year, we began with the goal of developing a centralized database for Purdue control that can be live image. This involved working with Purdue's AIT, who did a lot of the work getting the API set up for all the Purdue customers. We chose Soxworks as a portal, and so AIT is doing a lot of work with the awesome people at the Seago. This included weekly meetings between the collection and AIT working closely with the species file group to get the API set up, utilizing the species file group weekly drop-in meetings, me asking them a questions in their Slack channel regarding issues with data uploads, and the work of going through and cleaning up huge geographic profiles that have been done multiple different years. Collaboration is a continual iterative process, and this is how we go Purdue AIT and the species file group. So I really want to make sure that we are giving them credit this year. They've done a lot of hard work, and we're absolutely right in this process. And now, without further ado, I'd like to show you a virtually recorded tour of Purdue's new database. This is a site recording, so we're moving kind of fast. As you can see, we already have over 10,000 records entered in the database. The database includes an expandable taxon tree of all the record specimens, a statistics table that includes total number of records at each taxonomic level with both valid and paternity, maps of georeference specimens at species level currently, and the ability to download a CSV file of the data. I know that was kind of fast, I'm sorry. This is just the beginning. We plan on getting all of our previously digitized data to the portal very soon, advancing the search options so that you can use any field present in a dark file, enhancing the the statistics table and work on map collection at characterized map levels and any other suggestions that you might have. The QR code on this current slide is to the Git code page for the database, which includes all of the API information that you might need if you want to dig into that kind of thing. And with that, I would like to give a special shout out to Nature Baker and the grandson children of Reduce and IT. We really could not have done this without them. They've both done a huge amount of work. So helpful. I would also like to shout out to all of you lovely people at the 65 Hackathon Works with. It's been so amazing to work with and endlessly patient. And it's just a wonderful experience all around. I also like to give thanks to Chris Worth and Aaron Smith, as well as any current and former personnel who have made this role. The QR code on this slide is for you to check out the collection yourself. And so that's many over there. Slides. And with that, thank you all so much for listening to my talk. I really appreciate it.
Resources, two pieces of structure. The structure, the word. Structs these structures from them. As totally see as totally these are really effectively as a vehicle for the process. Jesus.
But also, impression, during this process. Needle cases, composite structure, a highly standardized individual, partially executable, and resolute reinforcement and regions that undergo the most tension. This brings us to a spotlight specimen, selected in September of 2023 from Ohio. This is a farm with a skeleton head of a female eagle. This eagle was rooted in against the drilling to the parents who were in her body, leaving only the head skeleton in place. And it is meant to lost resilience, and it was beautiful that slender snout remains skeleton. We can say we should be strong easy for doing what it says, and most of these little diagnostic characters have been needed. Replogle is just another demonstration of superiority of needle technology.
Many people have been solved in the making also giving one of the set of Microsoft science as a and the service in particular for having developed the secret method for deep fluid mounts, as you see here, in which the specimen is kept immediately in the deep cell, which allows preserving its original 3D structure. He was also a photographer and illustrator lecturer. He had many talents, but not simultaneously probably mostly remembered for his role minority and is often credited with creating the term very fast for the country. So according to the actions that he discovered in minority and his goal, actually was scientific, an exhibit by Frederick Stitch called A Very Fly, called Dale-Skey, and of course, if the story is true, you know, can be credited with creating the term for the country, so there is an interest in finding more about this exhibit. And there is reason to believe that you know, through connection with this first encounter, because in different portions of the story, the details of the specimen is that a beautiful specimen against the dark background, which immediately does our and other details vary, in particular when activity of Waite and when with this ranging from 1872 to 1870. So the first specimen, I was interested in the result of 1870 when we moved in 1876, and then we studied all the and the final single record of the lady is as very fine. No, indeed, the single instance of the term very fine is at all. For the key technique itself, the most likely candidate will be this one, of the library and in fact, this is because it was the original pitch exhibit in Linux biography. The only problem with this is that while pitch is has been independent, has been thinking, so maybe it could still have been back in the text for here in 1870, and here in 1871. So, I think we can accept that, first encounter with minority was in the form of a beach technique. But I don't think it was with as fairly far. Yeah, he credit the fact all the time. The right answer it is a little each side on each one and the zero four. But I mean, in a school, you can be trying to find. And I hope your attention with parallel. Again, the law, I also the original piece. And that is why I love that side so much. Trying to recreate this speech specimen that is going practically and which he had loved it. And so it was love at first sight, and my friend, it was also a lifelong love. You can see it, she because my friend is in his week. Thank you.